Hello together. Today I would like to talk about the next steps for this electronic fuel injection prototype you can see here. This prototype currently has several points that need to be improved. Thanks to everyone who actively provided feedback on my last video. Let us now address each point individually and see what we can improve. Chapter 1. The solid-state relay. I used a solid-state relay. This is okay for a prototype, but ultimately not suitable. The maximum switching frequency of 5 kHz is rather low. It is very large, and it breaks down after approximately 1 million switching cycles. The solution to the problem is a transistor, or more precisely, a transistor switch module. These have a switching frequency of at least 20 kHz, are small, and have nearly infinite switching cycles. This is the transistor switch module, which you get on eBay for only $1. At the end, we will stack 5 pieces to get fully functional switch module for all 5 injectors. Chapter 2. The fuel pump. Let's be honest, the fuel pump in the prototype was much too big. What was worse was that it was also leaking. Just look at how big it is. It's longer than the entire engine. Many people ask me where I got it from. It's also from eBay and costs $30, but unfortunately, it's not worth the money. So I decided to build one myself. I started drawing the new fuel pump in CAD. Here you can see how it looks like in theory. The concept was clear. It would be a gear pump with seals and a brushless motor. The gear pump itself is a 3-part sandwich construction with laser-cut seals. The inlet and outlet are arranged axially. This is what the gear pump looks like from the inside. 2 gears pump the fuel. The central gear drives the system, and the off-center gear is driven. On the right is the inlet, and on the left the outlet. The function is simple. Fuel is sucked in at the inlet. The fuel is pumped into the space between the teeth to the outlet side. The trick here is that the teeth seal in the area where they interlock. This is what it looks like in reality. I hope you can see that quality is very important to me. This is what it looks like when you turn the motor manually. The gears should turn smoothly and with little resistance. As mentioned, the individual parts of the sandwich construction are sealed with laser-cut 0.25 mm thick abalone gaskets. They fit so well, it's fantastic. It was very important to me that the pump be completely leak-proof. I don't want fuel leaking everywhere. It's also a safety hazard. For this reason, I equipped the motor shaft with a radial shaft seal. It is simply the cleanest solution from a technical standpoint. I did have some space issues, but even that was solvable. Perhaps a few words about the manufacturing process and size. The gears were very complex. They are really very small, and precision is crucial. For example, the teeth are cut free with a minimal collar. This collar prevents the gears from touching the housing and causing chips when the pump is running. The finished gear pump is smaller than my hand. It is 50 millimeters long and has a diameter of 30 millimeters. While I was at it, I made more than one. There are 4 in total. For future engines, you know what I mean. Now let's test the pump with fuel. I would say that we have successfully solved the fuel pump problem. It is now significantly smaller and no longer leaks. Chapter 3. The microcontroller and the electronics. This is the electronics from the prototype. I know, everything is improvised and big. The goal is not to change the concept. I want to make it smaller and better. So let's take a look at the parts. This is the Arduino microcontroller. Here is the voltage regulator for the solid-state relay and the microcontroller. The second voltage regulator is for the DC motor of the fuel pump. Here is the solid-state relay that controls the fuel injector. The power supply is a 4S LiPo battery. Here you can see the improved electronics mounted on the underside of the mounting plate of my VR5 engine. That's right, the VR5 will be my first engine with electronic multi-point fuel injection. But more on that later. The individual parts of the electronics remained the same as in the prototype, but were significantly improved. Here you can see the stacked transistor switch modules. Imagine if there were 5 solid-state relays. Unthinkable in terms of size. These control the 5 individual injectors for the VR5. Here are 2 3-amp voltage regulators. One supplies the Arduino microcontroller and the other supplies the transistor switch module package. These voltage regulators are only 20 by 20 millimeters in size. What's new is the control of the brushless motor. For this purpose, I purchased a 200-watt, 3-phase brushless speed controller. However, we only need 10 watts for the fuel pump. We can use the potentiometer to adjust the speed. I may control the speed directly via the Arduino later on. I chose an Arduino Due as the microcontroller. It has a 32-bit ARM microcontroller by Microchip with a clock frequency of 84 MHz. The operating voltage is 3.3 volts. This is one of the fastest Arduino boards and therefore perfectly suited to control my electronic fuel injection. People often ask me how I test these setups. Trying something on the engine would be far too risky. That's right, I never recommend going directly to the engine. I use a small lathe, my laptop, and an oscilloscope for this. Magnets are attached to the lathe's chuck. These trigger the Hall sensor, just like in the motor. The trick here is that I know the exact speed of the lathe, so I know what the Arduino should output. I then use the oscilloscope to trigger the signal directly from the Arduino and record it. Here is an example of the injection signal from cylinder 1 and cylinder 2 at 632 RPM. The injection signal has a voltage of 3.3 volts and a length of 3.0 milliseconds. With this method, I check the signals from all cylinders, including the timing sequence, and also different speeds. That's it for this video. In the next part, I'll show you how I made the 5 throttle valves, the fuel distribution system for the individual injectors, the wiring for the injectors, and many more. Thanks for watching the video. Please like, share, and subscribe to my channel.